Okay, so hello everyone. So today I'm going to discuss you some of the non-parametric methods. So I hope you have gone through first introduction session, and also there we discussed the one sample sign test. So we discuss one example also. And then I ask you to try example number 2 and come. Did you give a try? Were you able to calculate, or were you able to find the answer for example number 2? Okay, let's have a look. So it says the following data are IQs of arrested drug abusers who are aged 16 years old. So they're asking, is there any evidence that the median IQ of drug abusers in the population is greater than 107? So you have to use the significance level as 0.05 and you are given with the data set, right? So in this case, what you have to do, first step is you have to write down the hypothesis. So your claim is you have to test whether the IQ level of these drug abusers are greater than 107 or not. So first I'll write down the hypothesis, that is you have to write down H naught against, you have to write down H1. So I'll be writing H1 first because we always take the claim as H1. So since we have to check whether the median IQ is greater than 107, I'll write H1 as M is greater than 107. So when you write H naught, you have two options. I'll write it as M equal 107, or else you can write M less than or equal to 107. Either ways are correct, right? So you can use whatever the way you like. So in this case, as I told you, you have to define your parameters, right? So in this case, you have to write down what is M value. So the M is the median IQ level of the drug abusers, right? So now we have written our hypothesis that we want to test. Now the next step would be, what is our test statistic? So we know our test statistic is denoted by capital S, and in this case if you look at the alternative hypothesis H1, so you have the greater than equation, greater than inequality. So in that case we know our test statistic is n minus, right? Or in other words, you have to find the number of negative differences in your sample. So that would be our test statistics. So I'll just write capital S is here equal to n minus, right? So this is our test statistic. Now you have to find the n minus value. So what you have to do is you have to just take your data set, right? And then you have to check how many positives and negatives are there. So our value, the given median value is 107. So when you take the difference between the observation and the given median value, you can observe whether the difference is a positive difference or a negative difference. For an example, if you take the first observation, you have 99. So when you take the difference between 99 and 107, so we get a negative difference. So in this case, the first difference is negative, and then if you get, right, first difference is negative, and then if you go for the second, 100 minus 107, that is again negative, and then you have 90 minus 107, that is again negative, and then you have 135 minus 107, and that would be a positive. So likewise, you have to check what are the positive differences and what are the negative differences. So I'm not going to do the whole thing because I ask you to do this at home and give a try. And In this case, you can find out the number of positive differences and number of negative differences. So actually our test statistic is n minus. That is, we are interested about the number of negative differences. So in that case, if you count the number of negative differences, you will see you will get 6 negative differences, right? So you can check your answers now. So that is S equal to 6. Now we have found our test statistic as well. So the next point is we need to find the p-value, right? So we need to find the p-value of the p-value. So in that case, if you are going to find the p-value, so that is, we want to find the p-value is equal to probability, where our test statistic is less than or equal to the observed value of the test statistic. So the observed value in this case is 6. So I'll write 6. Given that our test statistic is having a binomial distribution, right? And here the sample size would be, when it comes to the sample size would be 40, because if you look at the observations, you can see when you look at the sample, you have 15 observations, right? But here you have 107. That is, you have here you have 107. So when you take the difference, it will be equal to 0. So in that case, we are going to omit this observation, right, from our data set. So we the remaining values, in the sample, we are remaining with 14 observations. So our sample size would be 14, and the probability of success is 0.5. Right, since this is a one-sided test, we are not going to multiply the p-value probability by 2. So you have to just straight away read this p-value from the binomial table. Let's read. So when it comes to the binomial table, in the first column we have the sample size. So in our case, the sample size would be 14. Right, so here this is the sample size, and this probability of a success is 0.5 here. So you have to read 14 and 0.5, and if you look at the number of x values, or the test statistic value is equal to 6. So at the intersection point, you have this value, that is 0.3953. So that is our p-value. Our p-value would be, this is equal to 0.3953. So now we can take the decision. So we can clearly see our p-value is greater than alpha, that is 0.05. So that is, we do not have enough evidence to reject H naught. We do not have enough evidence to reject H naught, right? So that is, the conclusion is, we cannot say that the median IQ value of the drug abusers in this population is greater than 107. Right? So I think by now you are clear with the one sample sign test, right? How to use it when you are given with the sample of data, whether it's a one-sided test or a two-sided test, you can apply the one sample sign test. So there is another question. Now in this case, when you are given with the data set, right, you can always apply this one sample sign test, but there are some cases where you can apply the large sample approximation in non-parametric procedures as well. So let's say when it comes to your sample, if you have more than 15 observations in your data set, then you can use the large sample approximation using the one sample sign test, right? So in that case, when you are using the large sample approximation, right? So in order to convert our variable into a standard normal variable, right, you have to subtract the mean value and divide by the variance, so in a standard deviation. So when it comes to binomial, we know NP is the mean value, variance is the NP into 1 minus P. So this is a special case where the probability is equal to 0.5 when it comes to one sample sign test. So you can replace the probability of success by 0.5, right? And here you can see is our test statistic. So we are going to convert it. It was having a binomial distribution. We are going to transform that into a standard normal distribution. So we have to subtract the mean, that is NP. So P is 0.5. That is why you have n over 2 here, and then the standard deviation would be n into p is 0.5, again p 1 minus p is 0.5. You have the whole thing square root. So if you simplify this, you have s minus n over 2 divided by 0.5 into square root n. So you can use this. This is actually what you get. This is the test statistic that we can use for the large sample approximation. But the problem is now when it comes to the binomial distribution, it's a discrete random variable. But when it comes to the normal distribution, we know it's a continuous random variable. So when you transform a discrete random variable into the continuous random variable, so there is a gap in between, because when you take the discrete distributions, when you take two possible values, there is a gap, right, where you cannot find that in the continuous distributions. So therefore, in order to do the corrections, what you have to do is you have to use the continuity correction. So as the continuity correction, what we do is we replace our random variable s by s plus 0.5. Right, so if you look at this equation, so in your note I have keep a space for you to write down. So here you have s minus n over 2, so s is our random variable, and here we are going to replace that by s plus 0.5. Right, so after applying the continuity correction, you have z equal to s plus 0.5 minus n over 2 divided by 0.5 into root n. So we can use this one when you have a data set which is greater than 15, right? In order to apply the sign test, you can use the large sample approximation. So we'll have a look on this example. Right, so it says the following data gives the ages in years of a random sample of 20 students from an education institute in Sri Lanka. So it is believed that the median age of students in this institute is smaller than 22 years. So based on this data, is there sufficient evidence to conclude that the median age of students is smaller than 22 years? So what can you do? So in this case, you have a sample where you have 20 values, right? So that is, you have more than 15 observations. So that is, you can apply the large sample approximation. So the first thing that you have to do is we can write down the hypothesis, right? We can always write down the hypothesis. So I will write down H naught and then H1. Okay. So when it comes to H naught, so they're asking us to find whether there is sufficient evidence to conclude that the median age of students is smaller than 22 years. So in that case, if I take the median as M, we have to find whether M is smaller than 22. So that is our claim. You have to take it as H1. So M less than 22 would be our H1. So the opposite of that would be the null hypothesis. So there are two options. You can, if you want, you can write it as m equal to 22, or else you can write it as m greater than or equal to 22, right? So this is our hypothesis. Now we are done with the hypothesis. So the next thing is we have to find the test statistic, capital S. So the test statistic in this case, we have the less than inequality in our hypothesis, in our alternative hypothesis. So because of that, we know the test statistic of such case when we are applying the binomial one sample sign test, that would be n minus. Sorry, but that would be n plus. So in other words, the number of positive differences in your sample, right? So this is our sample. When you take the sample, you can see we cannot find any value which is equal to 22. That is, when you take the differences, none of the differences will result as 0. So you don't have to omit any observations. So you can count the number of positive differences. So the number of positive differences, if you take the first observation 9 minus 22, you get a negative difference, right? So actually to get a positive difference, you need to get a value which is higher than 22. So the number of positive differences means, in other words, if you count number of values, observations which are greater than 22, it will give you the number of positive differences. So if you look at the values which are greater than 22, you have 1, 2, 3, 4, 5 values, right? Okay. Can you see? Yeah, you have 5 values. So your test statistic, I can write it's equal to 5, because only 23, 24, 25, 25 and 27, those are the values which are greater than 22. So you have 5 positive differences. Now we can apply the test statistic. Now we are using the large sample approximation, the Z value. So first in your numerator you have S plus 0.5. So S plus 0.5. So the S value is 5 plus 0.5. And then you have minus 0.5 into N. So here the sample size is 20, so that is n is equal to 20. And then you have to divide this whole thing, that is in your denominator you have 0.5 into root n. So that is, you have 0.5 into, you have the square root n. Right? So if you just simplify this, you will get 2 minus 2.0125. So this is our test statistic, right? So now actually this is coming from a standard normal distribution. So when it comes to standard normal distribution, we know how to find out the the cutoff points, right, in order to test whether we can reject or accept the null hypothesis. So when it comes to standard normal distribution, if I just tell you, let's say, so we have, if you have the standard normal distribution like this, right, we need to find the cutoff point. Now if you look at this one, if you look at the alternative hypothesis, you have the less than inequality. So that is when you take the less than inequality, so that is when we want to find out the cutoff point from the distribution. The cutoff point is lying in your right hand side, somewhere here. So we need to find this value from the standard normal distribution, right? So how are we going to find this value? So they have asked us to use alpha as 0.05. We need to, sorry, I'm sorry, this is a small mistake. So since you have, when you look at the H1, so there you have, when you look at the H1, you have the less than inequality, right? So that is the cutoff point should lie from your right hand side, left hand side, right? So that is somewhere here. So since we are given with the significance value 0.05, we can find this value, that is, if you write this value, this is mine, if you can write this value as Z alpha. So this you can write as Z alpha, that is 0.05. So from your left hand side, if you find this value, that would be equal to minus 1.645, close to minus 1.645. So now our test statistic, you can see it's equal to minus 2.0125. So it's lying somewhere here, even, right? Our test statistic. If you look at our test statistic, so our test statistic is lying somewhere here, right? So that is, the test statistic is lying in the critical region. So in other words, we can reject H naught, right? So we have enough evidence to reject H naught. So that is, if you write the decision, you can write the decision. So the decision is, we reject H naught and 0.05 level of significance, right? So that is, if you are going to reject H naught, that is, the claim is true. In other words, we are rejecting H naught, right? So that is, we are left with the median value is less than 22. In other words, our claim is correct. So as a conclusion, we can write the median age of students in this institute is smaller than 22 years. So using the large sample approximation, you can find out, you can make inferences using one sample sign test. Right? Okay, so using the sign test, using this sign test, we can also find confidence intervals, right? We can also find confidence intervals in that case. Now, if you want to find out, let's say when you take alpha as 0.05, 1 minus alpha is 9.95. So when you multiply 0.95 by 100, that is 95%. So if you want to find out 95% confidence interval, that means you will find two boundaries, the upper limit, the lower limit. So we are 95% confidence that our median value is lying in between these two limits. That's what we are finding by using the confidence limit, right? So in this case, what we are actually going to do is we are going to find out upper limit value and lower limit value using the test statistic of the sign test. So in that case, when you take a particular value, right, when you take the, let's say when you take the lower limit, so when you take the probability where your test statistic is less than or equal to this lower limit value should be equal to alpha divided by 2. Right? So in other words, if you are taking alpha as 0.05, alpha divided by 2 is 0.025. That is, we are sure when you take the binomial distribution, right? When you take the binomial distribution in this case, So if I just take the binomial distribution, the number line of the binomial distribution like this, so we are going to find two limits, right, from either sides. Now, right, we are going to find out one limit from here, and we are going to find out another limit from here. So this one is this one is mu, this one is ml, the lower bound, and this one is mu, the upper bound, right? So we are going to find out these two limits using the sign test, statistic, right? Because it's having a binomial distribution. So what happens here is, when you find out these two limits, these two values, when you take ml and when you take the distribution, the probability for any point to lie, the probability that any point in the population is less than this ml value should be equal to alpha divided by 2, because this area should be equal to alpha divided by 2. And if you take any value from your population, the probability for that value to be a greater than value for mu, that is, if the probability of getting a value which is greater than upper limit, again it should be alpha divided by 2, because this area should be equal to 0.025. So in order to find out these two limits, ml and mu, what you have to do is, first you have to arrange all the values in ascending order. That's the first thing you have to do, right? And then we have to find out this S dash value, right? I'll explain you using an example how to find out this S dash value. So we have to find out this S dash value, and after arranging all the observations according to ascending order, what we do is we take S dash plus 1 observation as our lower limit, and to find out the upper limit, what you can do is you can start counting from the back, and when you count S dash plus 1th value from the backward, then that would be your upper limit. Or else you can take the sample size minus S dash. In this position you can find a value, so that would be your upper limit, right? So let's see an example. Okay, so here you have a data set. You have to construct a 95% confidence interval for the median of the population from which the following sample data have been drawn using the sign test. So you have a few values here. So the first thing that you have to do is, if you are going to find out a confidence interval, you have to arrange your data set ascending order. But you can see here I have already arranged the data set in ascending order and has given you, so you have no problem. And then the next step is, first you have to find a point estimator. You have to find a point estimator. So in that case, if you are going to find a point estimator for the data set, the ideal point estimator would be the median value, because we are talking about the median value in non-parametric method. So we are going to find the sample median, right? So sample median you have to find out first, right? So you can see you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 data points. So that is, you have to first find the position of the median, that is 16 plus 1 divided by 2. Right, that is 17 divided by 2, that is 8.5. So that is, you have to take the 8th observations and 9th observation divided by 2 to find the median value. That is 1, 2, 3, 4, 5, 6, 7, 8 8th value is 3.08, 9th observation is 3.1. So to find the median, what you have to do is you have to take 3.08 plus 3.1 and then you can divide this by 2. Right? So then you will get 3.09 as a point estimator. Right? Then what we are going to do is we check the point estimator and we can see it's 3.09. Right? So we take the closest integers for the point estimator. In this case, the closest integers are 3 and 4. So what we do is we check the probability where our test statistic is capital S. It's less than or equal to 3 given that S is having a binomial distribution. Right, and in our sample we have 16 observations and the probability of success is 0.5. We are going to find out this value using the binomial table. So let's have a look on the binomial table. So the sample size is 16 here and then the observed value is 3. So here you have 0.0106. Right? So that is, you can write down this one 0.0106. Okay, and then again we can find out the same probability value. Right, since our point estimate is between 3 and 4, now here I have calculated the probability using 3. Here I am going to find the probability using 4. Right, let's check what is that probability using the binomial table. So if it is equal to 4, you can see the probability is 0.0384. So you can take this probability here. Right, so now what will happen? So if you go with this value, if you take S dash here as 3, you get the probability as 0.0106. That is, if you take S dash as this, the probability of this part which is lying on your left hand side of the distribution, this area is 0.0106. So alpha is actually double as this area. Right, so to find the confidence interval is the area, the confidence is in between these two values. So you have to subtract these two areas from 1 to find out the confidence. Right, so in this case, if you are using the S dash value as 3, what will happen? To find the confidence level, you have to take 1 minus 0.0106 into 2 and then you have to multiply the whole thing by 100. Right? So in that case, let's see what is the value. So you have to take 0.0106 multiplied by 2 and then you have to subtract it by 1 and then you will see when you multiply that by 100 you have 96.8. Same thing if you take the S dash value as 4. Let's see what will happen. So in order to calculate the confidence, what you have to do is you have to take 1 minus this probability is 0.0384. You can multiply it by 2 and whole thing you can multiply by 100. So that is 0.0384 multiplied by 2 minus 1 multiplied by 100. So you will get 92 0.32. So you can see actually when we are using the sign test, we cannot find a confidence interval which gives the confidence accurately as 95. Right, so if you take this dash value as 3, you will get a confidence interval with a confidence of 96.8%, and if you take this dash value as 4, you will get a confidence interval with confidence 92.32%. Right, so actually when we are finding confidence intervals, what we actually do is we go for a sometimes we want to, we cannot, when we are using the sign test, we cannot find the exact value. So what we are doing is we go for a wider interval but with high confidence, or we are going to select a narrow interval with low confidence value. Right, so in this case I'm going to select the S dash value as, I'm going to select this dash value as right, I'm going to select this dash value as 4. So in that case I can take S dash plus 1, that is equal to 4 plus 1, that is equal to 5. So that is in the 5th position, 1, 2, 3, 4, 5, I have 1.99. So that is my lower limit value is 1.99, and my sample size n minus S dash, right, so that is equal to, I have 16 observations in the sample minus 4, that would be equal to 12. So the 12th observation here, if you count the 12th observation, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12th observation is 4.01. right, so that is my upper limit value is equal to 4.01. So in this case, so when S dash is equal to 4, we can see the confidence is 92.32%. So that is, we can find a 92.32% confidence interval for this data set, which consists the median value, that is 1.99 and 4.01. Alright, so this is how, using the sign test, we are going to find the confidence interval. So I hope that is clear with you. Right? So the next thing is, what will happen? Now, I told you when we can when we have more than 15 data in your sample, we can go for the large sample approximation. So if you have a large sample, in that case we can apply the large sample approximation in order to find a confidence interval. So in that case, since we are using the standard normal table, you can accurately, you can precisely find, if you want a 95% confidence interval, you can very precisely find a 95% confidence interval. Right, so this is what you have to do. So our test statistic is S. So we know it's coming from a binomial distribution. So we want to find a value K, where the probability of our test statistic is less than or equal to K is alpha divided by 2. If you are going to find out 1 minus alpha into 100% confidence interval. So in order to do the large sample approximation, we have to subtract the mean, that is 0.5 into n, and divide by the standard deviation. Same thing we have to do for this side, right? And then you have, by simplifying this, here you have Z is less than or equal to K minus 0.5 into n over 0.5 into root n. So this is the probability is alpha divided by 2. So this particular value we can write as Z alpha over 2. So from the standard normal distribution, you know how to find Z alpha by 2. That is when you have to read the point where from that point to minus infinity, the probability should be alpha divided by 2. So if you find that figure from the standard normal distribution, then what we can do is by taking this Z alpha by 2 value, but Z alpha by 2 is equal to this term. So by equaling these two values, you can find the K value, right? So when you find the K value, we take the K value as S dash plus 1 value, and then using the previous procedure we are going to find out the upper limit and the lower limit. So I'll explain you from this example. So in example 3 you have a large sample, that is a sample which is greater than 15 observations. So we use the large sample approximation there. So if I use the same sample in order to construct a 95% confidence interval, this is what you have to do. So your n is 20. So that is, if you take alpha as 0.05, Z alpha over 2, that is Z 0.025, we know that is minus 1.96, because we know when you take the standard normal table from minus 1.96 to minus infinity, the area is 0.025. That's the value we want. And if you take K as S dash plus 1 and K is equal to this equation which is coming from this simplification, right? So if you substitute all the values, that is you have half, within the brackets n is 20 minus Z alpha by 2 is 1.96, again n is 20. So if you simplify this, you get 5.6. But what we do is when you get an integer, we round off to the next largest integer, so that is it's equal to 6. That is the K value, but K is equal to S dash plus 1. So that is S dash is equal to 5. So in that case, S dash plus 1th observation, that is the 6th observation, is the lower limit, and n minus S dash, n is 20, 20 minus 5 is 15. So the 15th observation would be your upper boundary. So if you just take the data set and if you arrange it in ascending order, you will see in the 6th position you have 16, in the 15th position you have 23. So a 95 confidence interval which consists the median value of the population would be 16 and 23. So likewise, using the large sample approximation and also using the sign test statistic, we can find confidence intervals as well. So based on your data set, you should be able to select what method that you are going to use. If it's less than 15 or exactly 15, you have to use the sign test, or if you have more than 15 data in your sample, you can always go for a large sample approximation. So I hope that is clear. We discuss all the things which is related to the sign test. So that is the end of the first chapter. So in the next session, I'm going to discuss about the Wilcoxon sign rank test, right? We'll see how in what kind of situations you can use the Wilcoxon sign rank test, and how you can do the calculations as well. So thank you very much.